Hey there, Year 11s. In this video, I'm going to show you how to solve circular functions. In this case here, we're going to do one where it's in degrees, so 0 degrees to 360 degrees. Personally, I would want you to work in radians, but just to get you to understand what they're trying to get you to do, let's do the first example together. In A, they're saying that cos of a particular angle will have to equal to root 3 on 2. What I want you to understand is when they say cos, they're telling you that somewhere on this unit circle that you have, right, all they know is that the x value, because cos represents the x value, remember? So the x value is root 3 on 2, right? So where could it be? Because it's a positive root 3 on 2. Where on the unit circle do you think you'd get the x coordinate as root 3 on 2? Now, logically, because x is positive, it can only be in, this could be an example of it, so it could be there, right here, that's where x is root 3 on 2. We don't know what the y is, but we know it is clearly a positive value. And then similarly, there has to be a y value that's negative, and that coordinate there is also root 3 on 2, okay? So that means that you get these two regions here. Now, they tell you that you're starting from 0 degrees, which is over here, you're starting here, and you're going to move throughout the unit circle until you reach 360 degrees. So essentially I'm moving around the circle and you reach back at 360, right? But in that process, how many times are you going to hit the solutions? And you can see that I hit the first solution at this point. Now the question is, cos of what angle? That's what they're asking. Okay, cos of what angle should you have to get an x coordinate root 3 on 2? And this is where you have to go back to your exact value. So if I just jump back all the way to 14f, we jump back right to 14f and look at our exact values here. Maybe I'll just copy that across, actually. I'll just copy this one across. Actually, I'll just look at it. You can see here they're saying cos, so we're saying cos of what angle, 30, 45, 60, 90, that will give you an x, the value of root 3 on 2. So you can see here to get root 3 on 2, the angle had to be 30 degrees. So that means when I go back to solving, I now know this angle had to be 30 degrees. Okay, so that means that when they say cos of what angle, we already know it had to be 30 degrees. But does 30 degrees fit to 0 and 360? Yeah, it does. Okay, and that's where you have to understand that we call this a base angle. You have this triangle. You know that in order to get a root 3 on 2 for your length, because that's the x value, right? The length is root 3 on 2. The angle has to be 30 degrees. But you see, if they didn't tell me it was 0 to 360, it could have been from, say, 360 to 720, for all I know, right? It just happens to be that it fits. But the point is, this triangle, this symmetry properties is what you're going to be using. So now that you know this is 30 degrees, the radian, on the other hand, radians means the distance that you would have traveled is pi on 6. That's the equivalence, right? So that means this triangle below here that I'm going to draw as well, by symmetry properties, this is also 30 degrees, and that means this is also a distance of pi and 6. So when we answer the question here, we start off by writing, okay, so cos of an angle is equal to root 3 on 2. To solve for theta, I need to remove the cos. So I'm going to do cos inverse of both sides. I do cos inverse of the right and the left. And we know the cos inverse and cos are inverses of one another, so they cancel out. And you end up with theta is equal to the cos inverse of root 3 on 2. So what you're figuring right now is, what is that angle? Because that's what you're trying to figure out. What is the angle to make sure that you get root 3 on 2? Well, we already know, starting at 0, so I'm going to draw my highlighter, starting at 0, I knew I moved 30 degrees up and I'd hit my first solution, meaning that's when it'll be root 3 on 2. So my first one was 0 degrees and I move up by 30 degrees because I used the exact value and I knew that to get root 3 on 2, cos of 30 will do that. And then once I got that point, I'm like, cool, that's one solution. But then I continue around the unit circle. I still haven't got root 3 on 2. It's all negative cos values right now. And then I come all the way here and I get again root 3 on 2. That's my x value. That's root 3 on 2. But then I know I only need an extra 30 degrees to finish off at 360. Okay, so that's why I can say, oh, well, I'm actually short of 360 degrees by 30 degrees. Can you see that? All the way up here is 360, but I only am short from it by 30 degrees. Okay, because that's what I know. I knew that I only need an extra 30 degrees to reach 360. That's why I'm saying 360 minus 30. And so the total angles, when I rotated from 0 to 360, I know that the angles, or the possible answers, were 30 degrees and 330. Okay, so for the first time, this would be a bit confronting for a lot of students to get through, but hopefully, as you can see now, I'm going to do sine and I'm going to do the other one, so B and C, and hopefully this makes a lot more sense for you. So B, we now have sine of an angle is equal to negative half. So what I want you to understand is, what does sine represent again? Okay, so I'm going to move this down. Sine represents the y values. They're saying the y value is negative half. So when I draw that unit circle again, let's have a think. This is my unit circle. We're saying the y values are negative half. So where is that? So negative half, say it's about here. That's negative half. So that means it has to be at this point or at this point. Those are the only 2 points where the y value, y coordinate is going to be negative half. That means I get these two triangles. Can you see that? I'm drawing these two right angle triangles. Those are my two triangles. But then you go back to your exact value and say, well, sine of what angle will give you a value of half? Okay? Because that's the triangle you're working with. You're trying to figure out, in this triangle here, I need the value of half. The distance is half, but what's the angle? And so that's where you go back to your exact values, and that's why you needed to memorize them. So in 14F, sine of what angle will give you half? And we can see again, it's 30 degrees. So that means, I'm going to go back to my picture again. I know this is 30 degrees. So that means over here, this is 30 degrees, and this is also 30 degrees. But that means the distance is pi on 6. And this way to this point is pi on 6. Okay? So now that I know that, I can now answer the question. Okay, so I'm going to sine inverse both sides again. So sine inverse both sides, theta is equal to the sine inverse of half. This is how you should be writing it. Okay, so theta equals, now we're moving from 0 degrees, so starting at 0. When I move across, I'm keep going around the unit circle. So far, all the y values are positive, but I want negative. Remember, it's negative half. So there's no point. I'm moving all the way here, and I get to pi. So right here is pi. Right at this point is pi. And then I'm moving from pi, and I continue a bit more, an extra pi and 6, or an extra 30 degrees. I now reach my next solution, or my first solution. So my first solution occurs at pi, which is 180 degrees, or pi, and I add an extra 30 degrees to get there. That's when I reach half, like a height of half, okay? Or negative half, sorry. And then I continue the circle again, and I continue past that solution, and I get all the way to 360 degrees, and I'm done. But when I reach 360 degrees, I again reached another solution. Okay, can you see that I reached another point where the y value is negative half again? And I know that was short of 360 by 30 degrees. So that's why I write over here, I would write 360 minus 30 degrees, because I'm short of 360 by 30. And so that gives me now 150 degrees and 330 degrees. See what I'm doing there? If you did it in radians, it would have been pi plus 30. Pi plus pi and 6 and 2 pi minus pi and 6. You just work in radians. In this case, they're getting you to work in degrees. Does that make sense? Are you starting to feel it? Yeah? Let's try another one. This time I'm now going to do the C version, and hopefully you're starting to pick up the pattern here. C, you want the cos of an angle, so cos is the x values, to equal to negative 1 on root 2. So again, I'm going to draw my unit circle. So here we go. Here's my unit circle. Cos is the x-axis, right? When is the x-axis negative? Well, negative is on this side, and I don't know where it is. So I'm just going to write here, negative 1 on root 2. That means there's only 2 points. This point and this point. Those are the only 2 points where the x-coordinate could be possibly negative 1 on root 2. So here we go. I got my two triangles. That's 1, that's 2, okay? What I don't know is what the angle is there. What angle, cos of what angle will give you a distance of 1 on root 2. And this is why you needed to memorize your exact values, and hopefully without going to our table now, I know that to get 1 on root 2, it is 45 degrees. Okay, which tells me the radian version of it is pi on 4. And this is also pi on 4. Okay, so now that I've got the diagram, I'm like, okay, so I'm working in the unit circle. To calculate this, I do cos inverse of both sides. Therefore, cos cancels out, so cos inverse on the left, cos inverse of the right, which is cos inverse of negative 1 on root 2. And this is where I write my answer. I'm like, okay, I'm going to work around the unit circle starting from 0 degrees, because that's what the domain was. 0 degrees, I keep moving around the circle, and I reach my first solution, right? But that was 45 degrees away from pi, which is 180 degrees. So I write down, okay, well, to get to 180 degrees, I was short by 45 degrees. Can you see that? Because reaching all the way to this point is 180 degrees. But if I just went back by 45, I get to the point I wanted. And then same thing, I move around the unit circle until I reach my next solution. And look at that. I reach my next solution over here by adding an extra 45 degrees from 180. So 180 with an extra 45. And together now I get, what is that? 135 degrees. And that's 225 degrees. See what I'm doing there? I'm simply using the unit circle because once I go all the way to 360, there's no more solutions that I could have gone. There's no way I would have gotten negative 1 on root 2 again for the x value. Okay, so that's how you would do example 19, and it will be very similar to example 17 with radians. It's just that I'm working with the degrees and it may make a bit more sense, but eventually you want to work in radians. Radians are much easier to locate on the unit circle than it is for degrees. Okay, and then I'm going to do example 20, which is the hardest one of them there. Okay.